Welcome today, everyone. My name's Andy Thomson, and normally at the RV show I'd be doing a 90-minute A to Z of towing seminar, but I don't think that's going to translate real well to video. So probably the most glaring problem out there with towing travel trailers is that most weight distribution hitches are not set up properly. So today we're just going to go through how to set up your weight distribution hitch properly. And what we'll start with is the ball mount. This is the ball mount piece here. And that's the most critical part of how you set the hitch up. If it's not done properly, you will never get that trailer to tow properly behind the tow vehicle. Now what's in this car right now is what we call a welded ball mount. The shank portion, the 2-inch square that goes into the receiver, is actually welded to the ball mount assembly. And that lets us keep the ball in closer. It's a little lighter to carry when we unhook. The problem with it is it only works if the heights line up correctly, and if you change vehicles, that ball mount's all welded together. You need to go with another one. So if you trade vehicles frequently, probably better to use a bolt together, and that's what most people have. So let's take that out of there, and we'll put together a bolt together for it. So if we're going to do a bolt together ball mount, this part is called the shank. So there's the spot where the pin goes through right here, and then this allows us to change the height and angle of the ball mount on there by bolting it together. This shank isn't very good. It's made out of cast steel, and we see when I put this in to where the pin would go, it's sticking way out behind the car, and it would actually go the other way around, pointing up. If you had a taller vehicle, it would point down like that. But you see, that's that far behind the car, and then if I was to hold the ball up here, you see how much extra overhang we've added, and that really decreases stability. The other problem with this shank is it's really loose in the opening. It's a little smaller than would be ideal. So that we're going to throw away and not use. So we have our own shanks made. This shank is for most applications, and again, it can be down if you've got a higher vehicle or up. If you have a really tall vehicle, a high SUV or a high pickup, and you need to get down lower, we use what's called a super drop. And you see this allows, it won't even go in here, well maybe it will, that allows a lot of drop. So if this hitch receiver was up this high, that would allow us to get the ball height down to where it should be. So we don't need that one today either. So the correct shank is this one. And we're going to put that in the upward direction. Normally it'd be painted, but I just thought it'd be a little easier to see. And you see we can get that in right to there. It's in much closer to the car, which is going to reduce the overhang, and it's much tighter in there. There's hardly any movement in it in the opening. So the next step is we need to know how high the ball's got to be for the trailer to sit level. And there's two ways to do that. One is I can measure to the top of the frame at the front and the back if I'm on a level cement floor like this and tell. If you don't have a level cement floor, the other trick is I can measure in here between the wheels, because that's going to give me a pretty accurate height of what the top of the frame is. So if I shoot in here, see it's 20.5 inches to the top of the frame on this particular trailer. And then my ball height on this trailer, this coupler design, the ball is actually an inch below the top of the frame. So I have a 19.5 inch ball height is what I want this to be. Now, I know that the car is probably going to sink about 1/2 inch when I hook the trailer on. So I probably want to start around 20 inches of ball height. The exception to that, if you have a more conventional trailer with leaf springs instead of the independent suspension that's on this trailer, you can actually run the front end a little bit low. It seems to clean up the airflow a little bit, helps keep air out from underneath it. So if you're an inch and a half low on those trailers, that's probably not a bad place to be. So once we know our height that we want, we can start to put the ball mount together. And if I take the tape measure here, the top of this shank is 18 inches. So I know that the top of my ball's got to be just a bit higher than that. And these big bolts are used to put it together. So probably right about there, I would think. And how did we wake out there? So that is just under 20 inches at the top of the ball. So that's what we'll go with. The next spot up would be 21, which would be too high. So now we've got the height set. We need to get this hitch on the right angle. The biggest, most common mistake in a ball mount is people put it together at a 90-degree angle. And, so they want it square. And as I always say, square is great in carpentry, but it has no place in suspension geometry. And the reason we want a rearward angle on the ball mount is it changes the way the bar transfers weight when you turn. So inside the hitch here, there's an adjusting screw that lets you adjust the angle that this hitch is going to have. By winding that out further, I can have the hitch sit on more of an angle. There we go. So if I lift this bar up here straight behind the car, you'll notice it's almost at the road. But if I pull it around here sideways, geez, we're about a foot off the ground. So if the trailer was hooked up to it and I was turned with it around sideways, that chain would actually be loose. It would stop working. It would be so close to the trailer frame. Here, straight behind the car, it's going to work really hard because this is going to be done up to the trailer frame. It's going to be transferring more weight. What that means is when I turn a corner and the trailer's off on an angle pointing that way, and this bar's over here, it stops working. The one on the outside of the turn that's going to have more pressure on it works harder. So my car doesn't lean over. My car stays flat in the turn. So at the time when you want the most stability, you keep the correct weight transfer just by having that angle on the ball mount. Simple little thing, yet almost never done right. So where I want this bar is I want it, right about there, about 4 inches off the ground without any pressure on it. It's going to come up higher when we hook the trailer on because it's going to actually bend from the force from the weight transfer. So so now I can go ahead, we have our angle, we have the height correct, we can go ahead and put these bolts together. This hitch has, for the slotted holes on the top, it has these large wave washers that go on, and those go on each side. And then so there's one on this side and one over here. They don't go top and bottom. They just go on each side of this bolt. And we throw the nut on there. And then on the bottom one, there's a lock washer for it. So we pop that on the bottom one. Now, this bolt here is what keeps this from going forward. On the bottom, there's another bolt that keeps it from going backwards. So we'll take the impact gun here. Of course, you can do this with a manual with socket and wrenches, but so we've got that tight now and in position. So now we can take that off, and we'll take this impact gun. This is almost always an 1.1/8" socket on any hitch that you'll do. And we'll tighten the top one. Now, maybe we'll get the gun going in the right direction. And we'll tighten the bottom one. Now, if I was doing those by hand right now, they'd feel pretty tight. But this is actually almost a little bit loose on here. So we want those really tight so that hitch, this ball mount's not going to work on the shank. It's a lot harder to get it tight on the cast steel shank. This one's a little larger. So we can put our gun on again and so if you're doing this by hand or you want to use a torque wrench, this gun's set for 300 foot-pounds, and that's about where you want to be. There we go. So now we're all bolted together, and we're on the correct angle. One of the most important things to do, this hitch ball has a lot of pressure on it all the time, especially at the front, so we need to keep some grease on that. And sometimes people ask, how often do you need to re-grease it? It depends a little bit where you've been driving. So you can drive from here to Florida without re-greasing the hitch because it's pretty much interstate the whole way. You're not doing a lot of turning. But you do 200 miles of the Cabot Trail, probably should grease the hitch again. Now the other spot that needs grease are the ends of the torsion bars here. The ends of the torsion bars have massive pressure on them, several thousand pounds per square inch when they're turning. So you need a little grease on here to keep, the front is going to take a lot of pressure and the bottom at the back. So you need those greased well. And they just, on this hitch, they just snap in like that to put them in place. So now I can go ahead and back the car in underneath the ball. Of course, my trailer's too low because I leveled it to check my ball height. So I got to raise the hitch up a little. That should do it. And we'll back the Tesla in here. So at this point here, we've got the ball underneath the coupler. We're ready to hook up. And you would think you'd go ahead and drop the trailer on the car, but you don't do that. What we have to do now is find out what the height of the car is without the trailer. And you'll see we have some masking tape on the four corners of the car here. And we're just going to pick a number, and we just want to get the height of the car without the trailer. So here we're going to use 26 inches. And I'll put a little note there, 26, just so I remember. And then we'll come back here, 26 inches. And then we're going to do the same on the other side of the car. 26. So you might wonder why we do all four corners of the car. And that's because if one torsion bar is bent or not working properly, or we've got something wrong in our hitch receiver, we'll know because the car won't go down evenly side to side. If the car's tipped one way or another, usually the steering will pull to the right or the left, and we'll have to tune that out. So by measuring it, we know that we've got it correctly. So now that we know how the car sits without the trailer, we can go ahead and drop the trailer on. And we're going to put the weight down on the ball. And at that point there, you can see there's just a little movement between the coupler and the ball mount. That's where the car's sitting. It's pretty much its neutral height. When we're hooking up a vehicle like this that has independent rear suspension, we don't want to raise the car way up in the air because it sucks the tires in and will mess up our measurements. So if we have a long vehicle, say a long Ford Expedition with independent rear suspension, we'll actually put a floor jack under the end of the bars to put the pressure on. If it's a pickup truck, something with a conventional live axle, we can go ahead and raise this up 6-8 inches, make it much easier to connect. At this case, we're just going to raise it just a couple inches, take the pressure off of it, and see what we get next. So now that we've got the car in and just raised up ever so slightly, we can put our bars in, and we can hook the chains up that are going to transfer the weight to the front wheels. So I'm going to start here with one link hanging loose. I'll show you when I get over the other side. That's not a lot of pressure. What's the next one like? Yeah, let's try there. So we've got two hanging loose. We've got a little bit of pressure on the bars. So we hook the chains up here. There we go. So now we've got the chains hooked up. Oops. And actually, I just made a mistake there. You should always put that pin in while you still have the bar on there, just in case it springs back at you. So then lower it down. I usually give it just a little bounce like that, just in case the car's hung up on its shocks, that it finds its center. So remember our measurement. We started with 26 inches on all four corners. So here at the back, we're now at 25 3/8. So the car's gone down 5/8 of an inch at the back. At the front here, we were at 26. It's gone down a 1/2 inch at the front. And on this side over here, we're only down 1/4 inch. So we're getting a little more pressure up to that front wheel on the far side. And then this one here, we're down 3/4 inch, so down a little bit more. So we're not getting quite dead even weight transfer with these bars, and we're just a touch heavy at the back end. So what we're going to do, if we went to the next link, well, let's go ahead and do that. We'll go up one link here and see what happens. Now we're hanging 3 links. So now our 26-inch measurement back here, we are only down 1/8 inch. It's almost unchanged. And at the front end here, we're down a full inch. So we really buried a lot of weight onto the front wheels of the car. And this side probably a little less again. Yeah, we're down 3/4 inch at this point. And back end here will be, again, down just about 1/8 inch. So we've got too much weight forward now. We've got quite a bit of weight added. Now, where we might leave this is if everything was completely empty and the trailer had a lot of storage in the front and the trunk was empty on the car and we knew people were going to add a lot more weight to it, then we might leave it at this point. The other thing is, if this hitch was all brand new, we might leave it at this point because we know that as you drive, the hitch is going to work in some. Where those bars go into the bottom of the head, the hole that the bar goes into is a little bit larger than the bar is. So there's a wear in for a while until the radiuses match. So right now we're hanging 3 links loose. As we bring these links up tighter, of course, we transfer more weight to the front wheels. When we were down 1 link with only 2 loose, we didn't have enough weight on the front wheels. So what we need to do is a part link. You might wonder how we do that. Well, we'll go through that. So first thing I got to do is disconnect again. So we'll take a little weight off the chains. So each of these links is roughly 1 3/8 inches long. So what I can do to get a partial link is to overlap 2 chains and put a bolt through. So you see these two chains here, and I always do this right close to the bar. I slide these two overlap of each other, put a bolt through, and you just need to finger tighten this nut on here. And now we have, this chain will be 1/3 of a link tighter than it was before. Now, if you may remember, we needed a little more weight on that far front wheel. It wasn't going down quite square. So I'm actually going to add a second bolt in here. So now this chain is 2/3 of a link tighter than it would be on the with two links hanging. So it seems like we're splitting hairs there, but that little bit of difference in weight transfer makes a big difference in how this tows and sits on the road. So we slip that up, put the pin in. Now on the other side, I'm only going to put in one bolt because we don't need any extra on this front, as much extra on that front wheel. And we're going to hang two links again. And so now we measure the back here. This corner we're down, see, we were 26 before. Now we're 25 and 7/16, so we're down roughly 3/8 of an inch at this back corner. And the front here, we're down 5/8 of an inch, so just a little bit more. On this side here, we're down, well, maybe not quite 5/8, 9/16, but very close to even. And back here, down about 1/2 an inch. So can't get much closer than that. Now, even though we're down a little bit of extra on the front end, 5/8 versus 3/8 of the back, that's probably where we would leave it, because that's probably going to be where this drives quite well. One factor in that is this car actually, it's unusual to almost any other vehicle. It has a stiffer rear suspension than a front suspension because the empty car is heavier on the back wheels than the front. So so we're probably actually achieving pretty close to even weight transfer with that amount of compression on it. And so that's it. We've got the weight transferred. So now that we have the height of the weight distribution correct, the one other part we'll put on this hitch is a friction sway control. So this is a very simple piece of equipment. Inside it are brake linings that squeeze on this bar. And this plate here is a leaf spring. When I tighten this handle, I adjust how much pressure I put on those brake linings on that bar. So when this goes on, I drop it on the ball here. Too tight. Swing it around, put it on there. Typically, you're going to put this rear pin in from the bottom, like that, and then I can tighten this up. And I can make that fairly firm. I don't want this handle pointing forward, or if it's there's a propane cover or something here, I don't want it in the way of that. Now, the sway control, you can leave those off and not miss them. If you have your weight distribution correct in a good tow vehicle and a stable trailer, you could drive all day and forget that you didn't put them on. Where they make the biggest difference is in an emergency maneuver. So a deer runs out in front of you, you whip the wheel to avoid the deer, you don't take the time to think, is the trailer on there? These make the difference between holding it and not. It gives it, slows down the reaction time, makes it easier to control the trailer. So they're just cheap insurance is what they are. You probably can't get them too tight, and we usually put two on, one on each side. If they're too tight, you'll come around a corner and the car will still feel like it's going down the road sideways a little bit. That tells you you have the sway control too tight. If you're, and that's really all you have to worry about is if it's too tight. The other spot you don't use them is if you happen to be on snow or ice. You might come to a corner and keep going straight. So you always want to be able to unwind the sway control when you're in conditions like that. The other time I might unwind them, they can tend to make some noise, especially when they get a little rusty like these ones. So if I'm going into a campground late at night, I'll unwind them on my way in just so that I'm not waking up everybody as I drive through the campground. You'll hear people say you cannot back up with the sway control on. Well, the sway control doesn't know if you're going forwards or going backwards. It just knows that the vehicle and the tow vehicle and the trailer are turning. So yes, you can back up with the sway control done up. If you make an extremely tight turn, tight enough that this little ball here is going to get around to the coupler on the trailer, you can get a couple more degrees of turn with the sway controls off, but that's the only time it's ever an issue. So this is a brand new hitch head here, ball mount, and a new torsion bar. And you see when it goes in the hole here, the hole is a little bit larger than the bar is. And the surface area that it can work on going down the road when it turns is very tiny. In theory, it's about 1/8 of an inch. As the hitch wears in, it wears in fairly quickly over the first few thousand miles, that hole actually becomes elongated a little bit. Now the surface area is the whole 90 degrees around the bar. And we have much more surface area, and once it gets to that point, the wear slows down very quickly. So you can do this measurement, set your trailer up. After you've towed it a couple of 100 miles, you might start to feel a little light in the steering. And that's when you know you got to put another bolt on each side, that hitch is worked in that little bit. And after a couple of 100 miles, you might need your first bolt. After that, it might take 500 or 1,000 before you need the second bolt. Usually when you notice it, you're driving on a windy day and you go, this just isn't planted like it used to be. You stop for gas, stop for lunch, raise it up, put a couple bolts in. You'll know immediately when you head back out on the road that you've done the right thing. As I said, after you've driven a few thousand miles, that will pretty much stop and it'll stay where you've got it. So if you've driven a car, pickup truck, just about anything where you had the back end of it, the trunk or the back of the box overloaded, you get that kind of a feel of sway in the back of the vehicle just by itself, and your steering wheel feels really light. That's a good indication that you don't have enough weight up to the front wheels of the tow vehicle. If you're driving along and the back end feels skittish, like it's almost top heavy, then that's a good indication you have too much weight on the front wheels. It's going to always tend to go towards being too much weight on the back, because as the hitch wears in, it's continually putting more weight onto the back wheels until you pull it back up again. And these measurements are great, but when you drive it is when you really know for sure that you have it set up correctly. But this will get you a very close start. So today we've used our Tesla and a 27-foot Airstream to do this. Mainly use that because the frame's very open and it's easy to get shots around the hitch. This is just as important if you have a 3/4 ton pickup truck as it is with this car. The weight distribution being correct and the setup being correct really matters. Before you go buy a new tow vehicle because you weren't happy with the handling, always check your hitch setup. And there's other little things you can do like tires and that sort of thing as well. Thanks a lot for tuning in today.